all.
Very good afternoon, sir.
Yeah. Today class will be on methodology for empirical research. So, why it is empirical research? Because that mostly we are depending upon data to conduct our research. So all kind of data-based or fact-based research is known as empirical research. There is another way to conduct your research, that is a kind of theoretical research, which is not followed mostly, because developing theory and again publishing, that will take lots of time and effort, and at the end also you may not get appropriate result or the expected outcome. So sometimes your theory may be challenged by any other scholar, so your theory may be invalidated. So that's why what happens when there is already existing theories are all, then what we can do, only we can collect some data, or maybe source or maybe from primary source, and using data we can able to prove that whatever theory that is basically we can prove using data, that we have already proved using data. So theory, from theory, whatever inference that you are getting, basically you will try to draw same inference from the data. What you can do, simply you can collect the data and you can do your research. So we are conducting any kind of empirical research. Basically, there are total 8 steps that to follow to conduct our empirical research. So any kind of empirical wherever you will do, so you need to follow all these 8 steps. So maybe the models that you are using here may be different. Maybe econometric models you can use, maybe you can use some other methodology, because some methodology are in management also. But the process that you need to follow all these 8 steps. So this is the broad steps that we are discussing. Sound is coming. We can.
Neelam, madam, can you? Yeah, now it's been switched off.
Okay, thank you. So the first steps that we have here is the statement of theory or hypothesis that will be discussed. The second one that will try to specify the mathematical model that will be based upon the theory, and the third one will be the econometric specification, or you can say statistical specification of the model. Then once the 3 steps are followed, then the next step will be to collect the data, and after that we have to estimate the model, that is known as estimation of the parameter. Then we'll have to test the hypothesis, and after testing, that means after validating the model, we can go for prediction or forecasting. And once that is over, then we can use the conclusion or inference for policy purpose. So these are the 8 steps. So sir, please go to the next slide, please. Sir, next slide, please. So here basically we will try to explain all these 8 steps using one famous theory called theory of consumption. Okay, that theory of consumption is basically developed by Keynes, James Keynes. Okay, so in 1930s, James Keynes has developed this theory of consumption, which states that when income is increasing, consumption is also increasing, but less than proportionately. So when income is rising, consumption is also rising, but less than proportionately. That means the rate at which income increases, consumption does not increase at that rate. Okay, so it is always less than that, right? So when it is always less than that, so say for example, if your income is 100, then you are not consuming 100% of the income. Okay, so some part will be consumed and the rest part will be saved. Okay, So that means the total income will be divided into two parts: consumption and saving, right? So, so that means when income is increasing, consumption is also increasing, but that is increasing at a lesser proportion than the increase in consumption, than the increase in income. So please go to next slide. Yeah, thank you. So the first statement here is statement of theory or hypothesis. Okay. So I told you what is the statement. That means on an average, consumers' income increases, but at the same time, the consumption also increases. And consumption increase in consumption is always less than one. And here basically the technical term is MPC. Okay, MPC is always less than one. What is MPC? MPC is the marginal propensity to consume. Right? Marginal propensity to consume. I will tell you what is MPC. That is change in consumption due to change in income. Okay, so change in, that is delta C by delta Y. So C is the consumption expenditure, Y is the income you can consider. So that is delta C by delta Y. So that is your MPC, marginal propensity to consume, which should always be less than one. So this is the theory or statement that is given by Keynes, right? And this is a part of your macroeconomic theory. Okay. So those who have already studied macroeconomics, maybe those who are familiar with economics, they can able to understand that this is one of the famous theory, Keynes consumption function, so which is saying that MPC is always less than one, right? So this is a kind of statement or the theory or hypothesis that basically we are getting from economics. Okay. Then once this is done, we can specify our mathematical model. Okay. So the mathematical model here, because we know that there are only two variables associated with this theory. One is consumption and second is income. We can write our mathematical model using both variables. So y is equal to beta 1 plus beta 2 x. Okay, where y is your consumption expenditure, that is a dependent variable, and x is the income, that is the independent variable, or we can say explanatory variable. So this beta 1 and beta 2 both are constant. Okay, so beta 1 is the intercept and beta 2 is the slope coefficient. So this is what we have studied in 12th standard. That is the statement of that is equation of straight line, right? So we have studied this in 12th standard, which is the equation of straight line, where y is equal to mx plus c. Okay, so this is a similar kind of equation that we have got here, and your beta 2 here is nothing but that is the MPC, marginal propensity to consume, which will always be between 0 to 1. That will vary between 0 to 1. Okay, so
Dr. Dalei, if you can, because students are not able to hear the MCP, the marginal, just tell them slowly, and also with delta, you try to explain why it is less than 1 in the statement of theory or the hypothesis, please.
right. Okay, sir. Okay, sir.
Yeah.
So when I am saying that MPC is always less than 1, so MPC is basically marginal propensity to consume, right? So what the law is saying, that when income is increasing, consumption is also increasing, but less than proportionately, right? So that means the rate at which income will increase, consumption does not increase at that rate. It is always less than that, right? So what does it mean? Out of total income, some part will be saved and some part will be consumed, right? So that means there will be some part which will be consumed. So what we can do when we calculate MPC, basically we will try to see how much is the change in consumption expenditure due to change in income. Okay, so whenever you have income, definitely you will have to use some part of income to consume, right? So what is the change of consumption expenditure when there is any change to the income? So that is your MPC. So that is the marginal propensity to consume, and that is nothing but slope of your equation. Okay, so when you have the equation like y is equal to mx plus c, So in this case, that is the equation of straight line. Y is equal to mx plus c. That is the equation of straight line that you have studied in 12th standard. So here, what is m? M is your slope. Okay, slope of the equation or straight line, and that slope m is nothing but here it is beta 2. Okay, so beta 2 is the slope of the equation, or that is the coefficient of x variable, that is dependent variable. Okay, and what is your beta 1? Beta 1 is nothing but y is equal to mx plus c. So c is constant, c is the intercept. So that is your intercept. Beta 1 is the intercept. In this diagram also you can see that in x-axis, when income is increasing by 1 unit, then how much consumption is increasing? Consumption is increasing by beta 2 unit. So that beta 2 unit is nothing but your MPC. That is your delta change in consumption expenditure due to change in income, right? So if you consider y as consumption expenditure, that will be delta y upon delta x. So where x is the income. So when income will change by 1 unit, then how much consumption will increase? Because always consumption will increase. It is not declining when income is increasing. So beta 2 unit consumption will increase by beta 2 unit. So that is your MPC. Is that fine, sir?
Yes, sir. Thank you.
Okay, sir. Please next slide. Sir, can you go to next slide? Okay. So students, we have already decided our mathematical model, right? So let me tell you some more things about the mathematical model, which is y is equal to beta 1 plus beta 2 x. So this mathematical model is exact. Okay, it is exact because in mathematics we know that left hand side and right hand side, they are all always equal. Okay, left hand side and right hand side both will be equal in case of any mathematical equation or any mathematical model. So that we know. We have already studied that. So the relationship there is exact. So when I am saying the relationship is exact, it is not practically true. Okay, it is not practically true. Why? Because your income is one variable which is impacting your consumption expenditure, right? Because income is the independent variable which is basically impacting your consumption expenditure. But is it only income which is impacting consumption expenditure? There are many other factors which can also impact your consumption expenditure, right? So say for example, size of family, age of the members in the family, family religion. So there are many factors. They are impacting your consumption expenditure. So along with the income, some other factors are also impacting consumption expenditure. So when this is the case, but we are not capturing those factors in our model. Okay, only we have two variable. One is consumption expenditure and second is income. So then what to do, and why we are not using those other factors in the model? Because of some limitation. Say for example, because of the cost involved with the survey, we may not able to collect all the information. Okay, sometimes the information are not accessible. Okay, and sometimes the information will be very costly. So in that case, what we can do? We have to ignore those factors because we cannot use. So instead of ignoring those factors, we can club those factors into one single integrated factor, and that we can call as disturbance or error term, or random error term, you can say, or stochastic variable, you can say, random variable, you can say. Okay, so that we can consider as u in the model. You can see here, it is highlighted in yellow color. So that is your u. U means it is disturbance term or error term or random error term, you can say, or stochastic term. So why it is there? Because some of the factors are not observable, and why those factors are not observable? Because of some limitations. Limitation means it is not possible to collect those factors because they may not be accessible due to some reason. Maybe the cost is there, okay, or some other reasons are there. So that's why we are clubbing all those factors into one single factor, and now we are adding those that single factor into our model, and variable, random variable is added to our model, then this model is known as your econometric model, right? So now try to understand the difference between mathematical model and econometric model. In econometric model, you have a random component, okay, along with the deterministic component. So here your x is a deterministic component. So you have a random component also u, okay. So your y variable is divided into two parts. One part is your deterministic component, that is x, and the second part is the random component, that is u, because u is not observable. Let me tell you, u is not observable, that is random, okay. So that's why we have used the random factor here. Sir, please next slide. So when u is not observable and we have used that as a random factor, and that is that we are saying that all those factors we have ignored in our model that can be clubbed together to form u. Similarly, there is another way to define u also. Okay. So here, just see this graph here. Okay. So when we'll plot consumption and income in a scatter plot, okay. So you will see all these dotted points. Okay. Although all those dotted points are available here, you can see those points. Okay. So on an average, you can see on an average that is rising upward. Okay. On an average that is rising upward. What does it mean? There is a direct relationship between consumption expenditure and income. Okay. So that means it is saying that consumption and income both are rising upward. Okay. They have a direct relationship, and the relationship is rising upward on an average, I am saying. Though there is if you join all those dot points, black dot points, you'll get a curve like this. But on an average, it is rising. Okay. So that's why when we are saying that on an average that is rising, we can draw a trend line like this. Okay. The trend line that you can see, a straight line is shown here, that is drawn. Okay. So that straight line is nothing but that is a regression line. Okay. So that straight line is nothing but that is a regression line, which is showing the average relationship between consumption expenditure and income. Okay. So it is showing the average relationship between consumption expenditure and income. Once again, I am telling you, this is showing on an average, it is showing some kind of relationship between consumption expenditure and income. Okay. So then what is all those dot points? When we'll measure the distance between the dot points and the average line, then you'll find some deviation. That means all those dot points are nothing but deviations from the average relationship between consumption expenditure and income, right? So the deviations, they are all positive and negative deviation. Okay. Above the deviation, above this line, there is some positive deviation, and below this line, there is some negative deviation. But they are all okay. They are all random deviations, and we can also consider those deviations as your random component. Okay. So any point on this straight line or on this regression line is known as the deterministic component. Okay. And any deviation from this line is known as random component. So the total consumption expenditure, I can say, when we'll draw a perpendicular line from any dot point to the y-axis. Okay. That is the total consumption expenditure, right? So the distance between the average line and the y-axis, that is the deterministic component, and the remaining part is your random component. So so that means the random component is also there, and that is defined in two ways. One is that when we'll club all those factors which are not considered in the model, and second is the deviation from the average relationship between consumption expenditure and income. I think it is clear to all of you. If you have any doubt till now, please let me know. Students, do you have any doubt?
Let's carry on. I think
Yeah.
they can see it on the PPT, so that's why it is much convenient. Yeah.
Okay, sir.
Yeah.
So So when the mathematical model is developed, uh, and one more thing, before discussing about data, I will tell you one more thing about the mathematical model. Okay, so the mathematical model is basically that is showing a functional form between your consumption expenditure and income. Okay, so once that relationship is there, we will assume that the relationship may be linear or non-linear. Okay, so here in this case, we have assumed that it is linear because we are considering equation of straight line. Okay, so so once that mathematical model is developed, then we have written the econometric model. Okay, so in these models, we have identified one thing, like we have identified some of the variables in the model. So some of the variables are associated with this model. Okay, one is your consumption expenditure and second is the income. Okay, so from the model, try to identify the variables. Then only your next step will be collect data on those variables. No need to collect many variables. Okay, sometimes what happens, the usual mistake that we are basically doing while conducting our survey or primary survey, that we are listing many variables to collect the data, right, without developing the model. So when we'll come back and we'll sit in front of the computer, then we come to realize that we have collected around 50 to 100 variables, but only 5 variables are useful for our model. So try to develop the model first, try to identify the model first, then go for data collection. Okay. So here after developing the model, we have collected the data. When we'll collect the data, there are two ways to collect the data. One is the secondary source and second is the primary source. Okay, so if the data in secondary source is not available, you can go for primary survey, right? And but here this kind of data are available, like the GDP we can consider as the income, and a personal consumption expenditure we can consider as consumption expenditure at macro level. So the data here it is showing from 1982 onwards. Okay, so we can collect the data from these sources. Sir, please, next slide. Once the data is collected, then your next job will be to plot the data. Okay, why will plot the data immediately before analysis? Because once you plot the data, you can able to understand the nature of the relationship between both variables. Okay, whether there is a linear relationship or there is non-linear relationship, that you can able to understand. If there is a linear in relationship, then you can write a linear model. Okay, or you can assume that you have a linear regression model. But if there is non-linear relationship, then what you can do, you have to either estimate the model using non-linear regression, or you can convert the non-linear model into linear model. Okay, so for example, when you have a kind of exponential relationship between variables, simply you can take log to both sides, natural log to both sides, and in that case, your model will be converted into a linear one, or you can say that will be a log linear model. So linear in log. So that you can always do. So that's why after collecting the data, first hand you have to plot the data to understand the nature of relationship between both variables. From next slide. So the fifth step is estimation of the econometric model. Okay. So what do you mean by estimation? Estimation means to find out value for all the constants associated with the model. So what are the constants here? One constant was beta 1, second was beta 2. Okay, so beta 1 was your intercept and beta 2 was your slope coefficient, right? So we have to find out value for beta 1 and beta 2. That's all. Okay, in order to find out the value for beta 1 and beta 2, we have to follow some standard procedure to estimate the model. So there is regression analysis. Using regression analysis, we can able to estimate the model. So when we will try to estimate the model, basically we will use some formula, okay, of beta 1 and beta 2. So using that formula that is basically available in econometric analysis, we can able to estimate the model. That is the theory part, that using this formula we can able to estimate the model. But the most importantly, nowadays so many softwares are available. So using software, quickly you can able to estimate the model and you can get the value for beta 1 and beta 2. Okay. And one more thing, that you can ask me one question here, that what happens to the random component or random variable in, because that is not showing here. I'm not showing that here. Okay, so this is a very important question, and what we are trying to do, that we are assuming that on an average the random variable or the mean value of the random variable will be equal to 0, or you can say on an average the random variable will be equal to 0, or you can say the mean value. When we are estimating the model, we are trying to find out average relationship, the mean relationship. That's why the mean value of the random component will be equal to 0. Why it is so? Because you can see that the positive and negative deviations will be cancelled, okay, and you will get 0. Okay, some of the deviations from the arithmetic mean is always 0, that you have studied in the statistics. Okay, some of the deviations from arithmetic mean is always 0. So that's why here we are assuming average relationship. So the deviation from the average relationship is always 0. Okay, so that's why it is 0, and we are not considering that. Okay, so that is 0. And here the model is just
You are not audible, sir.
estimate. So, and we got the value for beta 1 hat. Okay, that is minus 184.08, and beta 2 hat, that is 0.7064. Okay, so once the model is estimated, then the next step will be testing of hypothesis or hypothesis testing. Okay, so here we assume that our MPC is always less than 1. Okay, we have assumed that MPC is always less than 1, and we come to know, or we observe that MPC is 0.70, which is less than 1. But we have to prove this statistically that it is less than 1. Okay, so using some hypothesis testing, we have to formulate null hypothesis and alternative hypothesis, and we have to prove, and we have to take a decision whether to reject the null or to accept the null. And in that process, we'll try to prove that the MPC, which is equal to 0.70 that we got from our model, that is less than 1. Okay, so that we have to prove statistically. So when we'll study hypothesis testing, you can go through the theory of hypothesis testing, and you can able to understand that how to conduct the hypothesis testing. Okay, so that is a part of your assignment. You can go through, and that you can do. So next, and the next for one more, for seventh step, yes. Then the next is forecasting or prediction. Okay, so once you have tested the hypothesis and you have validated the model, then using same relationship you can able to predict or forecast for the future. Okay, so you got the average relationship between both variables. So using that, because of if the model is valid for the period 1995 up to 1995, then same model will be valid for 1997. So simply you can only use the income variable. Okay, in place of x, replace the x by income amount for the year 1997, and you will able to get the consumption expenditure for the year 1997, which here it is coming out to be 4,951.3. Okay, so one more point just I want to tell you, that suppose your data for the year 1997 is available, but you are not using that year 1997 in your model, rather you are using till 1996, and you have estimated the model. Okay, then again predict and forecast the model till 1997, and you will get consumption expenditure, that is the predicted consumption expenditure or forecasted consumption expenditure, and at the same time your data for 1997 is available, consumption expenditure data is available. Take the difference between the actual value and predicted value. Okay, so the difference itself here it is coming 37.82, which is nothing but your forecasting error. Okay, forecast error. If this difference is very minimum, then you have a very good model, and you have your prediction or forecasting is accurate. So sir, next slide please. Okay. So the last step is use of the model for control of policy purpose. So suppose we have the estimated consumption function. Suppose further the government believes that consumer expenditure of about 4,900 will keep the unemployment rate at its current level of about 4.2%. What level of income will guarantee the target amount of consumption expenditure? If the regression result given here seems reasonable, then simply you can do your arithmetic and you can find that you can able to find the consumption expenditure which is equal to which will be equal to here. The income will be 7,197. So you can able to find out the at a given consumption expenditure of 4,900, your income will be derived as 7,197. That is approximately okay. That is an income level of about 7,197 billion dollar. Given an MPC of about 0.70 will produce an expenditure of about 4,900 billion dollars. So as this calculation suggests, an estimated model may be used for control or policy purpose. So by appropriate fiscal and monetary policy mix, the government can manipulate the control variable X, that is the income variable, to produce the desired level of the target variable Y. So that means whatever inference you will draw from the relationship, okay, from the estimated model, that you can always use to take the decision or to suggest the policymakers that they can revise the policy, they can reform the policy. So, sir, next slide, please. So this was all about your process of estimation using econometric models for your empirical research. So these are all 8 steps. Okay, these are all given here. So if you have any doubt, because why I have taken this topic to deliver, because whenever you do any kind of research, you will have to follow all these 8 steps initially. Okay, then only you can able to find out something which you can suggest to the policymakers to take some decision. Thank you very much. If you have any query, any question, feel free to ask me.
Sir, you may suggest any research paper or the source. So I would suggest, especially Aditi, Shaurya, who would do this kind of job, so that in their research, so that if there is any research paper or a book you would recommend, so that they will note it down.
Okay, fine. First of all, this is the econometrics. So the basic textbook for this subject is Econometrics by Damodar Gujarati. You can note down basic econometrics by Damodar Gujarati. I'll also mail you, sir. Details I'll mail you also.
Yeah, please, sir. Any question? We have less than 1 minute left. Anybody in the class?
Yeah, any question?
Because I understand econometric, anybody who here is for the first time, they really find it difficult to absorb. But this is, I'm telling you, one of the most important session that we have it. So if you understand the sequence, any question? So if you don't have a question, I would suggest you do reading behind for this, and I'll send you the reading material, which Dr. Dalei will send me. So with this,